In this video, we're going to solve radical equations. There are a few steps for solving radical equations. We want to make sure we follow them very carefully. The first step is to isolate the radical expression. Oh my, we're having some issues. We'll see if this fixed it. Yep, looks good. So the first step again is to isolate the radical expression. Means get the square root, the cube root, whatever root it is, all by itself. Anything that's outside of the radical, you want to move to the other side of the equal sign. Once you've isolated that radical, you're going to undo that radical by squaring, cubing, etc., both sides of the equation. Once you've undone the radical, then it becomes what I like to call a baby equation, a simple linear or quadratic equation that we have plenty of options on how to solve. Once you've gotten your solution to that baby equation, you then must check your answer in the original problem. Make sure you use the original equation and absolutely make sure that you complete this third step. In these types of equations, we run the risk of an extraneous solution. Unless you check for them, you won't identify them as extraneous. So let's practice solving a few. The square root of 3x minus 2 equals 4. The first step is to isolate the radical, which we can see that radical expression is all by itself. The second step is to undo that radical. Since this is a square root, we're going to square both sides. When I square the square root, they cancel each other out, so we're left with 3x minus 2 on the left-hand side, and 4 squared is 16. And this is the baby equation that I was referring to a minute ago. This is really straightforward, and we're very comfortable solving these. Add 2 to both sides. 3x equals 18. Divide both sides by 3, we get x equals 6. Now, many of us just want to circle this and move on to the next one, but we need to train ourselves for radical equations that we have to check that answer in the original equation. So I've got the square root of 3 times 6 minus 2 equals 4. 3 times 6 is 18. 18 minus 2 is 16. The square root of 16 is 4, so 4 equals 4, and that's true. So x equals 6 is our solution. The square root of 9x minus 2 minus 2x equals 0. In this problem, we have to do that first step by isolating the radical. We want to get this piece all by itself. So to do that, I'm going to add 2x to both sides. And now we have the square root of 9x minus 2 equals 2x. To undo the radical, since again it is a square root, we're going to square both sides. When I square the square root, they cancel each other out, so we have 9x minus 2 on the left, and then we want to simplify 2x squared. Remember those properties of exponents. That 2 is distributed to both the 2 and the x. Another way you can think about it is 2x times 2x. This is 4x squared. When we see the x squared, we need to think quadratic. And when we think of a quadratic equation, we set it equal to 0 and we factor. We want our lead coefficient positive, so instead of moving the 4x squared to the other side, making it negative, we're actually going to move the 9x and the 2 to the right-hand side. So now we have 0 equals 4x squared minus 9x plus 2. Since the lead coefficient is 1, we're going to use the AC method to factor this. Making use of my margins, I'm looking for factors of 4 times 2, which is 8. That's sum to negative 9. That's going to be negative 8 and negative 1. And now I'm going to rewrite that quadratic, splitting up that middle term. So this is 4x squared minus 8x minus x plus 2. If you compare this quadratic right here, if you can follow my cursor, to this one over here, it's the exact same expression. All we've done is rewrite it. And the reason we do that is because then we can factor by grouping. We can factor, from the first set, we can factor out a 4x, and we're left with x minus 2. And then from negative x plus 2, since that lead coefficient is negative, we're going to factor out a negative 1, and we'll be left with x minus 2. They both have a factor of x minus 2, so that is my first factor. And then 4x minus 1 is my second. So this we're just going to plug back in over here. We have 0 equals x minus 2 times 4x minus 1. Now we set each of those factors equal to 0. X minus 2 equals 0, or 4x minus 1 equals 0. And we solve these two equations. We'll get x equals 2. And from this one, we're going to get positive 1/4. Now we're still not finished. We need to check both of those solutions in the original equation. Since I don't have any more space here, I'm going to erase what we have. So our solutions were 2 and 1/4. And now we're going to go through checking. The first value I'm going to check is 2. Plugging into the original equation, this looks like the square root of 9 times 2 minus 2 minus 2 times 2 equals 0. We simplify underneath the radical first. 9 times 2 is 18, and 18 minus 2 is 16. 2 times 2 is 4. And the square root of 16 is 4. 4 minus 4 does equal 0, so I know 2 will work. But I also have to check 1/4. I was just verifying that that was the correct solution because I didn't have the work. The square root of 9 times 1/4 minus 2 minus 2 times 1/4 equals 0. 9 times 1/4 is 9/4 minus 2 minus 2 times 1/4 is going to be 2/4, which will simplify to 1/2. Now working underneath that radical, 9/4 minus 2, in order to solve this, we need, or to combine these two, we need a common denominator, which is going to be 4. So what we actually have underneath the radical is going to be 9/4. I'm not sure what's going on with our pen today. Uh-oh. Okay, let's try to retrace, guys. 9/4 minus 2/4. Ooh, crisis averted, I think. Doesn't look as good, but it works. In this radicand, we have 9/4 minus 8/4, which is 1/4. So underneath the radical, we've got 1/4 minus 1/2 equals 0. And the square root of 1/4, since both 1 and 4 are perfect squares, is 1/2 minus 1/2 equals 0. And that's true. So we just tested both of our solutions and we find that they both work. Sorry about those technical difficulties, guys. We'll see if it continues through the rest of this video. The cube root of x minus 5 plus 2 equals 1. Step 1, we want to isolate the radical, so I'm going to subtract 2 from both sides. We have the cube root of x minus 5 equals 1 minus 2 is negative 1. Be very careful. This minus 5 is underneath the radical, so we can't move it to the other side. Anything that's underneath the radical has to stay underneath the radical until you're finished with that second step. Since this example has a cube root, to undo the cube root, we're going to cube both sides. Just like in the previous problems, the cube root and the cube will cancel each other out, so we're left with x minus 5 on the left, and negative 1 cubed is negative 1. Adding 5 to both sides, we get x equals 4. Just like with the square root equations, with the cube root equation, we have to check our answers. And I'm plugging that into the original. So we've got the cube root of 4 minus 5 plus 2 equals 1. 4 minus 5 is negative 1. And the cube root of negative 1 we can actually simplify, remembering that the cube root has a domain of all real numbers. So you can evaluate cube roots for negative numbers. If this had been a square root, we would have been in a different situation because we cannot take the square root of a negative. So the cube root of negative 1 is negative 1. And negative 1 plus 2 does equal 1. So x equals 4 is our solution. Now I know you're probably thinking all of these answers work. Let's look at this next one. The square root of 9 plus x equals x plus 3. The first step where we have to isolate the radical is already done for us. This square root's already by itself. So now we go to the second step where we are going to square both sides. And again, we're squaring because the index is 2. And look at what I'm doing. I squared the entire left-hand side, and now I'm squaring the entire right-hand side. If you watched the previous video on properties of exponents, we know that this exponent of 2 right here, we can't distribute to the x and the 3. Whenever we have that binomial being squared, what we're going to do is write it out twice. X plus 3 times x plus 3. The square root and the square cancel each other out, so we have 9 plus x on the left. It's very important to write that binomial twice because now that we see it written twice, we recognize that we're going to have to FOIL. 9 plus x equals x squared plus 3x plus another 3x is 6x. 3 times 3 is 9. Now, similar to not the last example, but the one before that was pretty long, we've got an x squared in this equation. So we're thinking quadratic, we want to set it equal to 0 and try to factor. Since we want to keep the x squared positive, we're going to move the 9 and the x. So on the left-hand side, we're left with 0, and we've got x squared plus 5x plus 0 when we combine like terms. And we want to factor this, so looking at it, since it's a binomial, see if there's a GCF. In this, we have a GCF of x, and when we factor out x, we're left with x plus 5. And now when we set both of our factors equal to 0, we get x equals 0, or x plus 5 equals 0, which we can solve to find that x equals negative 5. So again, we have two solutions. We need to check them both in the original. We'll check x equals 0 first, but there's no real need to pick one over the other. The square root of 9 plus 0 equals 0 plus 3. 9 plus 0 is 9, and the square root of 9 is 3. We end up with 3 equals 3, and that's good. That works. Now we plug in negative 5 for x, so we have the square root of 9 minus 5 equals 5 negative 5 plus 3. 9 minus 5 is 4, and the square root of 4 is 2. Negative 5 plus 3 is negative 2. 2 does not equal negative 2. So that tells me that this solution of x equals negative 5 does not work. It is extraneous. And our only answer is 0. It is important in your work that you show that one of the solutions is extraneous. Notice I went back. I had x equals 0 and negative 5 in my work, but then I went back and I crossed out the negative 5 because it doesn't work as a solution to this equation. A 20-foot ladder is leaning up against a building. If the base of the ladder is 4 feet away from the building, how high up the building is the top of the ladder? For these types of word problems, it helps if you set up a figure. You draw a picture for it. So imagine what the problem is describing. It's describing a ladder leaning up a building. So think of like an apartment building or something. And I'm going to draw that picture. So here's my apartment building. Here's the ground. And then here's my ladder leaning up against it. Now what we want to do is identify what shape we just made. We made a right triangle, didn't we? So thinking about a right triangle, solving equations, we're going to be using the Pythagorean theorem, a squared plus b squared equals c squared, where a, b, and c are talking about the three sides of the triangle. So now we want to go through and label the three sides of my triangle based on the description from the problem. The ladder itself is 20 feet. Well, this diagonal is representing the ladder, so my hypotenuse is 20. It says the base of the ladder is 4 feet away from the building. This is the base of the ladder, the bottom. It is 4 feet away from the building, which gives me that value. And then they want to know how high up the building is the top of the ladder. This is our x. So substituting these values into the Pythagorean theorem, we've got x squared plus 4 squared equals 20 squared. 4 squared is 16. 20 squared is 400. We can subtract 16 from both sides. X squared equals 384. And in previous examples, when we had a square root and we wanted to undo it, we squared both sides. Now we've got a square. So how can we undo that? We undo that by taking the square root of both sides. And because of the context of the problem we're dealing with feet, it is appropriate to use a decimal for this answer. We'll use a decimal rounded to 2 decimal places, or the hundredths place. So if you use your calculator, find what the square root of 384 is. We get approximately 19.6 feet. I'm sure there is another decimal after the 6, but I don't have that recorded here. So take a look at yours. Typically speaking, though, you're going to be asked to round to the hundredths place. Read the directions. If there's any questions, you can certainly ask me in the middle of the test. So that sums up our discussion on radical equations. Just to highlight the important parts, always start by isolating that radical, and at the very end, make sure that you check your solution in the original. Those are the 2 steps that we seem to have the most trouble with. We recognize that if it's a square root, we want to square both sides. In one of the examples, we emphasize that when you're squaring the left and the right side, you want to use parentheses. In the case where we had a binomial on one side, we have to square that entire binomial, and then we have to FOIL, okay? So think about those tips and tricks as you guys are working through your homework problems, and bring any questions you guys have to class. We'll see you next time. Thank you.